So on a periodic table, you see a layout like this for each and every atom. We're going to use chlorine as our example today. So for a chlorine atom, it has an atomic number of 17. This usually denotes the number, not usually, but it always denotes the number of protons. So the protons in the atom. That usually doesn't change unless you're talking about radioactive decay. Next, we have our chemical symbol, which gives us, what element we're working with, and the name of that element, in this case, chlorine. Now, at the bottom here, we have 35.453. It's the average atomic mass. We know the mass of an atom depends on the number of protons and neutrons in the nucleus. So if my mass depends on the number of protons and neutrons, and one proton is one atomic mass unit, one neutron is one atomic mass unit, those are whole numbers. How did we get a decimal here? We got a decimal here because this is an average atomic mass. An average of what? Well, we'll get to that in just a moment. So in the atom, we have protons, neutrons, and electrons. Let's take a look at what happens when those change. So when things change in the atom, certain things happen. So first, if a proton were to change, you know that the proton gives the atom its identity. So usually protons don't change very much, especially never in our chemistry class. But in some particle chemistry, particle physics, when they collide particles together, you can change protons. Or in radioactive decay, which we'll have a lesson on in the next video, things can change. Electrons, when they change, atoms become ions. We're very familiar with that by now. We know what ions are. Ions are simply charged particles. You can have positively charged particles or negatively charged particles. Chlorine would gain an electron and become negatively charged. Now neutrons. We haven't talked about that much. When neutrons change, what happens? When neutrons change, we form something called an isotope. And that's the take-home message for this video. We form an isotope. An isotope is simply when atoms have the same number of protons, meaning they're the same atom, same identity, but a different number of neutrons. It's kind of like twins. Twins have the similar or the same DNA, but one might be a little heavier than the other, too many meals or something. But in nature, where this comes from is that in nature, if I were to pick up a sample of chlorine, elemental chlorine, in that sample, I would have two different atoms. Well, sorry, they are chlorine atoms, but the atoms will have different masses. Some of the atoms will have a mass of 35 atomic mass units, and some will have a mass of 37 atomic mass units. If we take the weighted average of those, we get the average atomic mass that we find on the periodic table. Let's take a look at that. So in nature, if I took a random sample of chlorine gas, I'd have chlorine 35 and chlorine 37. Now this number 35 is our mass number. It says chlorine has a mass of 35. Now we know the mass number is the mass of the atom. The mass of the atom comes from protons plus neutrons, and that should equal our mass, 35. Now, we know that chlorine always has the same number of protons because it's chlorine. That's 17 protons. So I have 17 protons plus some X number of neutrons. It should equal 35. From this relationship, we can calculate how many neutrons this atom has. And it would be 18 neutrons. And we just said that isotopes are when atoms have the same number of protons, but different number of neutrons. So let's look at this one over here, chlorine 37. Chlorine 37, that 37 is the mass number. And it says that I should have protons plus neutrons equaling a mass of 37. From this relationship, again, if I have 17 protons, plus X number of neutrons should equal 37. If I do this math out, I'll have 20 neutrons. So they're both chlorine, meaning they both have 17 protons, but they have different masses, which makes them isotopes. Same number of protons, different masses due to the differing in neutrons makes them isotopes. Now, this is how you would write an isotope, chlorine-35. Sometimes it might be Cl, or sometimes the whole chemical name might be written out, chlorine-35. Like this. This is how you denote it. Another way to write it means the same exact thing, but another way to write it is like this, with the elemental symbol, and above you have 35, meaning the mass number of chlorine, and below you'll have the atomic number, meaning 17 protons. And the same thing here, 37, 17. In some examples, you might not even have the atomic number. It might be written this way. And that's okay because we know that chlorine always has 17 protons, so there's really no reason to write it. But what we're really interested in is the mass number. Hope this helps, gentlemen. This lesson on isotopes.